Okay, so we're going to get started with the fourth class here, and this one is kind of completely different than the other classes we've had. I'm wondering, with just our small group here, experiences with correlation and regression. Have you guys ever done that, know about that, seen some of
At
that?
least a decade.
So it's been a long
I
time.
have done it, not recently. It's been a few years.
So let me kind of give you the setup of the equation here. We've been covering things for the last couple of weeks. We started week one with the chi-square, where you have frequency, it's a nominal, and how many in this and how many in that. For the other two sessions, we were always dealing with kind of one manipulated independent variable and then a dependent variable that was continuous. And so the situation, starting with correlations, is what do you do if you're measuring two variables that are continuous? Let's say you take something like a lot of people in the health sciences are interested in things like age, right? So one thing that sometimes happens with age is you get people's ages and then you give them surveys and ask them various things about X, Y, and Z. And if you want to do a t-test on that situation, then you kind of take, okay, we got the 20 to 30-year-olds, young, 30 to 40, middle, and so forth. You kind of take a continuous variable and you categorize that.
Right.
And that's one approach to use, but that's taking data and kind of manipulating it, because then you could say, okay, I got 3 levels of this, and then I'm measuring that, and I can do an ANOVA. But age itself is a continuous variable. And so when you're dealing with continuous variables, maybe more than one, you're doing surveys, you're giving out questions, and you're measuring all sorts of continuous things, then that's when you do correlations. Correlations are used, Pearson product correlations in particular, are used when you have basically 2 or more continuous variables. They're very popular in the health sciences because many times people like to do surveys, and then you just ask people a lot of questions. You don't really manipulate anything. You just collect a lot of data and you run correlation and regression analysis. So with correlations, you look at the relationships between continuous variables. Does that?
Yep.
So I wanted to provide kind of a very simple example here. Let's say we are interested between the relationship of weight and sleep apnea. You guys know much about sleep apnea? What happens when people have sleep apnea?
They wear a CPAP.
Yeah,
They
don't breathe.
They
When I
stop
wake them
breathing
up at
intermittently while they're sleeping.
They don't breathe, and then eventually what do they start doing?
Well, they do breathe again, but it's
Yeah.
And how do they breathe? They
effectively.
gasp. Give me more than a gasp. They snore. They snore a lot. So one way that you could operationally define sleep apnea is by snoring episodes. And so one thing that you could do is you could do a study. Does weight have anything to do with sleep apnea?
Yes.
What do we know about weight and sleep apnea?
The higher weight, the more likely they are to have that happen.
So we could measure BMI. Is BMI a categorical or continuous variable?
continuous.
Continuous. Snoring episodes or frequency of snoring is a continuous variable as well. And so I've given you, if you look at the handout here, just a simple little thing with 5 people, because this is teaching statistics, so we can just go with 5. And so with the 5 people, does it look like there is any relationship between BMI and snoring here?
Yes.
Yes, it does. What does it look like is going on here?
As the BMI goes up, the episodes of snoring are increasing.
So as BMI increases, so does snoring episodes. So correlations can be measured basically from +1 to -1. So your statement about as BMI goes up, so does snoring episodes, that would be a positive correlation, right?
They're both going in the same direction.
They're both going in the same direction. You could look at BMI and quality of life, and what would you probably find with BMI and quality of life?
An inverse relationship.
An inverse or a negative relationship. So correlations measure relationships between variables, and if you look at this, it looks like there is a relationship that as BMI goes up, so does snoring. And once again, this is a very simple thing that a lot of health science people like to do, because you can just ask people questions on surveys, and psychologists are more into, I want this group over here and that group over there, and I want to manipulate things and test DVs. Health science people many times are more interested in just getting lots of information and then doing things. Now, many times health scientists are interested in gender as a variable, and then you can do t-tests. It's not a really manipulated variable, but you can still do t-tests and other things on those situations. So you can run a correlation on this, and actually what I've shown you here, so I think what I'm going to do is I'm going to go through the sheets of paper here and then actually show you how it's actually run with SPSS, that if you actually ran a correlation, very easy to put in 2 columns into SPSS. It'll run a Pearson product correlation. Do you know the difference between a Pearson product correlation, which is what this is, and have you heard of a Spearman correlation
I have,
before?
and that's another one of those, I go and I look at the book and I go, okay, which one of these should I use? I have no idea, yeah. I've
So-
heard of them, but I couldn't tell you why you use one over the other one. Or what
So
the difference
if you're working with ratio or interval scales, you use the you use the Pearson product.
Say that again?
If you're working with ratio or interval scales where there's a 0 and a 0 means something, you do the Pearson product. If you're working with a situation like order in a race that the horses came in, or more ordinal-based data, then you usually use a Spearman. There is a debate, and actually I was chatting with, who's the PA guy again?
Harold.
Harold. Likert scales. You guys use, actually it's Likert, but you guys
Yes, we
may-
had that conversation in a faculty meeting that somebody actually met Dr.
Likert.
Likert, and it's Likert, not Likert.
It is, but
I need liquor when I'm working on my Likert skills right now.
there is some debate on whether or not Likert scales are ordinal or whether or not you can consider them racial or interval. In most of my situations, I consider them interval-based information, and I do Pearson product correlations. If it's a 1 to 7 scale or 1 to 5 scale, I run Pearson product
Is that something a
correlations.
reviewer might have like a bee in their bonnet over and
Yes.
call you on?
Yes, it is. Actually, I was
Change.
talking in my stat class today that sometimes what you do if you want to get it published is you say, I understand your point, I changed that, and here's what we did. Other times, a problem I've run into is some of the articles that I've read and some of the things I've published, like marginal significance. The reviewers don't understand statistics, and so I either choose to do what they tell me to do, or I say, well, we decided that based on X, Y, and Z, and A, B, and C, that the most appropriate approach that a statistician would use would be this, and so we chose this approach to use. If you would rather me use the other one, I can, but statisticians prefer this one, and because you're trying to teach people who don't know what the heck they're doing. And when we were looking in the psychology class today, we saw all sorts of errors in reporting statistics. If you get an F score less than 1, I mean, published research, peer-reviewed, where they were writing F 1 in 15 equals 0.15, P equals 0.9. Not only did the researchers not know how to do it, but the peer reviewers didn't know that. So, yeah, some people, and yeah, you just have to decide that. And if you ever run into that situation, you can certainly let me know,
Yeah.
and we can decide if it's worth the while on that situation.
Yeah.
Whether you fight the battle or not.
Right.
Yeah.
Yeah.
I've had to fight various battles because I know a lot about statistics, and I realize that sometimes when reviewers are looking at things, they don't understand anything, and so they're kind of talking from,
I reviewed articles where I didn't know what the statistics were.
so.
And I wrote back to the editor, like, do you want me to continue reviewing this? But this is out of my league.
I agree.
Mhm. So anyway, you would run a Pearson product correlation on this situation, and if you look at the results here, how does it look here? So it's the 0.915 situation here. Is that a high correlation, a low correlation?
It's a high correlation.
It's a very high correlation. The highest possible correlation value is? 1. So this is a positive 0.915, and it's basically agreeing with the statement that as BMI increases, so does snoring frequency. Is it statistically significant?
Yes.
Yes, because it tells you the p-value is 0.029, so you could write it out, little r. Make sure you use little r. Big R, I took a multiple regression class, and big R is a whole semester class. So little r, sometimes Word changes little r's into big R's, so don't let it do that. Little r, and then degrees of freedom. Now, how many people do we have in the sample?
5.
5. With correlations are always based on a straight line, so it's always number of pairs minus 2. So it'd be little r, I should have a pen here, little r, then in parentheses, what would it be? N minus 2, 3 equals plus 0.915, p equals 0.029. So kind of like, yay.
So a lot of times when we've written these out, you've had us do p less than. Why did you choose p equals this time?
So, if you get, that's a good question. The only time
Say it again, how you wrote it?
p equals 0.029.
I just want to make sure I wrote the same thing you wrote. Oh, okay, you got it.
So, if you ever get a value where the computer tells you 0.000, then you write what? P less than
0.05.
0.001 is what you write. In the old version of APA, it was considered reasonable to write p less than 0.05, but the newer versions for statisticians and psychologists and health sciences is if it is significant and it doesn't say 0 on it, you write out the exact probability. That's the nature of the game. If somebody doesn't do that, are they going to get flagged? Are they going to get hassled?
Depends.
Probably not. It
Right.
depends on the journal and the situation and the reviewers. But the right way to do it is if it's greater than 0 and less than 0.05, you write out the exact probability. If it's between 0.05 and 0.099, do you remember what we call that zone? That's marginal significance. Usually in that situation, you say this result is marginally significant, and you write out the R, and then you write out P equals 0.067 or whatever. And then if your P value is greater than 0.1, you write P greater than 0.05. It's a little tricky, but if you ever come across those situations and you need me to just write it for you, that's.
We had a faculty member at BCU who, you know, he was he wasn't a statistician, but he was a pretty high-level researcher. Again, NIH grant guy and all that stuff, but, you know, he didn't believe in marginal significance. It was either significant or it wasn't.
So some.
So he wouldn't let you even say that.
So it's a good point to be made. Some people are like that. I've talked to some statisticians who don't believe in marginal significance. I have and it is a debate. But for me, I think I showed you on one of the other weeks, you know, I ran my asthma study and I had 5 results that were marginally significant. And in my situation, I didn't want to say there's nothing here. I only had 6 people in that study. I wanted to say it was marginally significant. I didn't have enough power here. I probably have a type 2 miss. And so next year when I doubled my sample size, they turn that way. So journal editors and other people, you get differing opinions. If it's white line people, those people sometimes like confidence intervals.
Yes.
Because the line in the sand is kind of, what if it's 0.051? I mean,
Yeah.
we missed it by that much.
He was big on confidence intervals. Yeah.
Would be big on confidence intervals, and if it's 0.051, what I've also heard is get 10 more people and make it 0.049. So it's one of those scenes. So if you look at it, It is statistically significant. Real-world statement here. What would be the real-world statement here?
Lower your BMI.
Well, that would be the advice, but the real-world statement on the basis of
Oh.
this.
Would be that the research shows that there's a positive correlation between BMI and snoring, such that the higher the BMI, the more snoring episodes are likely to occur.
So there's just a positive correlation between BMI and snoring. The higher your BMI, the more snoring you tend to do. Notice that we say there is a relationship. It's a positive relationship. We cannot say anything about causality.
Well, that always cracks me up because I remember talking about this in statistics class.
So let's,
And then you hear the media report stuff all the time
Oh, yeah.
that are, from how they reported it, it's a correlational study, and they make these giant cause and effect claims, and I'm going, oh, no. They do it all the time in the media. I hear it
So
probably a
let's-
couple times a month.
let's go through 3 reasons why correlations are not causal. Maybe 3 reasons. I didn't put them on here, but 3 reasons would work for me. So what would be the first one? Let's say I do a study, and I do a study about the number of churches in a given geographical area and crime rate. Guess what that study would reveal? The more churches in a given geographical area, guess what's going to happen to the crime rate?
Probably the more churches, the higher the crime.
There is a positive correlation. The more churches in a given geographical area, the higher the crime rate. Would you want to make the statement that churches cause crime? No. Why not? So it's a correct correlation. You'd be saying nothing wrong, saying this is the way, but what's the problem with this?
It's not true. I don't know
And
how.
it could be that the churches choose to go where there's crime.
Where are most of the churches in this country located in terms of
Inner cities these days, yeah.
a lot of churches in inner cities
Where people are.
where there's a lot of churches and there's a lot of crime in the inner cities. So we have what's called the third variable problem. Because you have not manipulated a variable, you don't know if there's a third variable at work here. So it is a true correlation that the more churches per given area, the higher the crime rate, but that's because you've got the most churches in inner cities. I don't know, Baltimore seems to come to mind because there's been terrible stuff going on there recently. And it is actually a true statistic, but you wouldn't want to say causality there. So the third variable problem, you can't manipulate variables with correlations, so you can't make causal statements. Second example, let's say that I ran a study and I wanted to look at how much violent TV is watched and criminal behavior. So you look at violent TV watched, a continuous variable, and amount of criminal behavior for 40, 50 people. What would you probably find when you ran that correlation?
Another positive correlation.
Another positive correlation, the more violent TV you watch, the more violent your crimes are, or something like that. The
I've
more
heard
crimes.
people report that
Yeah.
on TV. I've
So
heard it.
the problem with that situation, though, is you'd like to say that A, TV causes criminal behavior, but what might also be true?
Criminals like TV.
Criminals like what kind of TV?
Violent TV.
So it's a directionality problem. Does A cause B or does B cause A? Because you're not manipulating a variable you don't know. So that's a second reason why correlations are not causation. The third situation, dating back a few years, the 60s. Kind of seeing a little bit of a repeat of the 60s in the last year or so. In the 60s, in the South, what happened a lot in the South in the 60s?
Discrimination?
A lot of demonstrations, a lot of riots and civil rights marches. And so there was a lot of that going on. And what they did is they ran some studies and they looked at the temperature on any given day and the number of riots,
Well,
Oh.
yeah.
which would make sense.
I'd rather a riot in the sunshine.
There you go, but let's go into how much sunshine. There's a Sunshine Act. Oh, that's a pharmaceutical gig. That's another story for another time. The idea is they measured the temperature on any given day and the number of riots that actually happened. And they found that when it was 80 degrees, you had X number of riots. When the temperature went up to 90 degrees, the number of riots increased. And even going up to 100, there were still more riots. But what do you think started happening to the number of riots when it got to be 110 and 120 degrees?
They went down.
So that's a curvilinear relationship. It is not appropriate to run correlations when you have a curvilinear relationship. Correlations are kind of based on straight lines. There are other things to do in those situations that we don't really want to know about right now because that's just the way of it.
However,
Go ahead.
questions.
Yeah.
For example, I was thinking about your data set example for BMI and snoring. Or no, it was BMI and happiness, like healthiness, quality of life. You said
Quality of
BMI
life.
and quality of life.
Yeah, just
and I was
created that.
thinking, like, if you have really, really, really crummy BMI, you also have really crummy quality of life because you're starving.
Yes. So that could be a curvilinear relationship. It would not be appropriate to run a Pearson product correlation in that situation because you usually do a scatter plot in most applications, and if you believe that the relationship you're looking at is curvilinear, there are other more high-powered statistical things to do to look at that, and it wouldn't be appropriate to run either a Pearson or a Spearman
But you
correlation.
would kind of know that by looking at your raw data.
Yeah,
So
that's
if-
why
if
you
you're
look in a
only
scatter
looking
plot.
with BMI, where in this case it was pretty high.
Yeah.
Right. But if you were looking at BMI that spanned a larger realm, and then it went
Right.
from low to really high, then you would maybe say, I have to do
Yeah,
something else with this data.
and the other thing that makes it sometimes inappropriate is if you have outliers.
Yeah.
If all the data looks like this, and then you got 5 or 6 just out in right field, that's why a scatter plot is sometimes done just to look at the nature of the data and see what's going on with that. So SPSS can do that type of stuff as well.
So is it possible that someone could do, I'm thinking it's possible someone could do research and they could pull the data and end up only getting part of a curvilinear relationship and not realize it's curvilinear because they only pull the data from a certain population.
That is possible. That's why it's always important before you run the statistic that a scatter plot is actually done so you can see, if it looks like this, a half circle, you look at that in a scatter plot and then you say, no, I shouldn't be doing this statistic here.
So you have to look at a plot before you can just
Yeah.
use the numbers.
You kind of do, and you have to, it has to be continuous and you have to look at a scatter plot. Other comments or questions? These are good points to be made. So third variable
remember
problems.
My statistics teacher in my graduate program was very big on that, the scatter plot thing, so yeah.
Yeah, so that would be the way of it. Let me stop the first recording here.